Perhaps the most perplexing concept in all of ladder logic PLC programming is relating the real-world status of inputs and outputs to their corresponding contacts and coils inside the ladder logic program. So I'm going to show you an example now that is often a source of confusion for students, but hopefully will clarify some issues. I have a simple program here where a normally open or examine if closed contact sends virtual power to a virtual coil. I'm going to change this contact here. Instead of drawing it as a normally open or examine if closed, I'm going to change it to a normally closed. If I right click and say change the instruction type, it says, well, right now it's an XIC, examine if closed. I want to do an examine if open. That draws it as a normally closed contact. I'm going to verify my program, and it says it checks out with no errors. So right now I have a contact here on bit number 0 on the input that is showing as a normally closed contact, and it is going to pass virtual power onto the coil every time the real life input is de-energized. In other words, anytime this virtual contact is in its normal status, it's going to be passing virtual power onto that coil. I'm going to download this program to the PLC, and we'll demonstrate how it works. So yes, I want to download. I'm switching out of run mode to program to do the download. And I'm going back to run mode. And yes, I do want to go online so I can see what's going on. So right now we see the virtual power on the two ladder rails over there, highlighted in red. I also see virtual power passing through the normally closed contact over to the relay coil, energizing it as well. Now in this state, I have the real life input, bit 0, de-energized. If I turn the real life switch on my PLC trainer, that is going to force this normally closed contact into the open state. That will cease to pass virtual power onto the coil, and that will turn off. There we go. I just turned the real life input on the PLC on. That opened up this normally closed virtual contact, stopping the virtual power from getting to the virtual coil over here, correspondingly de-energizing the real output on the PLC. I'll show you again, this time lifting the actual PLC trainer into view. So right here I have a switch. This is my input switch, bit 0. I can turn it on and off. You can see on the PLC itself, right here I have an input highlight. That's my bit 0 highlighting LED showing me the status of input 0. And right there I have the output bit 0. You notice how those two are opposite of each other. Just like I see on the program display, when I energize my input, as I'm energized right now, I force that input, the switch right there, to be in its open status, ceasing to send power to the coil. When I de-energize the real life input, I cause that virtual contact to fall back to its normal closed status, thereby passing virtual power onto that coil and energizing it. This is how I get a logical negation, or an opposite state between input and output, as I use a normally closed contact. One way to think about how this works, and works especially well if you're accustomed to hardwired relay logic, is you imagine this virtual contact being a relay contact that is energized by real power being applied to the input of the PLC. So if you imagine these real switches applying real power to the input of the PLC, and along all this strip of input terminals, you have a bunch of relay coils. Each one of those is being energized by a real-life input. Contacts for those coils show up in the program. So think of this as being a relay contact that is activated by that particular input channel. So when the input channel is de-energized, this normally closed contact will be in its closed state. That goes over here to a virtual coil, which you can think of as being another relay built inside the PLC, this time on the output side. When that virtual coil is energized, it's going to be closing a switch contact here, which is able to send real power out to a real device. When that output coil is de-energized, that relay contact in here falls to its normal open state and cuts the power to a real-life device. So that's one way to think about this, to imagine how it works, and to put it into terms that might be a little bit easier to grasp.